Hi everyone. My name's Doug Jones. I'm the CEO of Ignite Atlantic, one of the partners here, and I'm fortunate to be sitting by some of my friends and co-conspirators here, and we're bar buddies, as Fraser would call it. So just wanted to point out who's on stage here with me. So we have Fraser Gray from Sustane, Greg Wanger from Oberland Agriscience. Yeah, and Dave Roberts from Sustainable Blue. So just our topic is talking about circularity and collaboration, and just wanted to paint a picture of what we kind of spearheaded a couple of years ago. We were doing a project called the Sobeys Plastic Waste Challenge, and some of our partner organizations are in the room on that. And through that process, we were replacing styrofoam trays in Sobeys retail. And but after this process finished, Sobeys was talking to me and said, you know, what can we do about our food waste? Because Sobeys produces a fairly significant amount of food waste every day in their retail, and so we started looking at that, and you know, with some co-conspirators, we came together and sort of identified a bunch of Nova Scotia companies that were already doing very innovative things, but not necessarily collectively, and so we started to paint this picture with Sobeys food waste, recognizing that it came into Miller Waste was the main conduit originally, and what they were doing was aggregating some of the plastics and organic waste and sort of separating them. Did I lose it? Oh, okay. Sorry. So from Miller Waste, once we recognized there were homogeneous piles of plastic, homogeneous piles of organic waste, we started to think, well, who else is working in this space? And that's when I called this group to a bar meeting in Halifax and said, painted this picture of, well, what can we do with this waste? How can we create a circular approach to this? And started to look at, and they'll each talk about, you know, what they're doing, but basically taking the plastics and streaming it into Sustane, and Fraser will elaborate on what they do with that, but then bringing that organic waste to Greg at Oberland and growing these magical little critters, soldier fly larvae, and recognizing that soldier fly larvae can go into multiple pathways, which we're still working on, but essentially that soldier fly larvae, that organic, really yummy things that fish like to eat, were then handed over to Dave at Sustainable Blue, and he was able to grow salmon. And guess who buys the salmon? So what this kind of led to was a great collaboration with very innovative companies, but closing that circularity loop without any new investment. It actually created new opportunities for all these companies to collaborate. And it's sometimes just a matter of communication, like coming together and finding united ways to do things. And it's a great example. So maybe I'll hand it over to Fraser, and he'll talk about that kind of first step in this circular approach. So.
Sounds good. Thanks, Doug. A couple things. We have a saying: waste is a terrible thing to waste. So how do we turn that around? It's a really big problem. We all know about the problem. I won't get into that too much. It's got massive benefits, and I think what we're going to try and show you here today is that if you get together, great minds think alike, and that's very, very helpful, right? Each company on its own may be a lot smaller than the sum of the parts is. You know, is important. So we need control. I'll just keep talking. You want to give me that clicker because I'll just keep talking, right, Paul? Paul knows. But I think it takes a village is another statement. I think Mark St. Ange is here, Carrie's here. There's a whole, most of the people in this room who know us have been involved in helping us and each of these companies. So that's a little bit of the theme here today. And so I'll give you a quick little background. Sustane was founded actually 10 years ago. So thanks for all of you who've hung around there with us. Been around for 10 years working away on stuff. It's not been straightforward. Lots of stuff working well, but I won't focus on that today. I'll just focus a little bit more on the process and what we actually do. Some of you know it, but some of you don't. So full-scale commercial demonstration plant right here in Nova Scotia. Some of it's commercialized already. Some of it needs more investment. We're moving along the path. But what we effectively do, and this was the original vision, is try and take that stuff that nobody wants, that stuff that's headed to the landfill, and do the best we can at diverting that into products. Nova Scotia's got a great history and a very evolved history of separating things and putting them in the right places, and you all involved in that live here. But there's always something left over. We don't deal with it completely, but that's the mission that we're on, is to see what we can do to turn that back. Originally, the idea was, you know what, we can at least get some kind of an energy value out of the products coming out of that, and that was a bit novel. Some folks were taking it and waste and making electricity. It burns, it's an expensive way to do it. We were thinking about fungible products at the time, and that was the mission originally. But boy, has it ever changed. I think we've hung around, and I think the world's gotten a little different, and thanks to some of the guys sitting here with me who had a lot smarter ideas than we did. We now see it as a circular platform for waste. What I mean by that is we can take that waste product and move it into markets that can then use it again. That last group was talking about effectively insetting. We now are going to be able to produce products that are going to have a negative impact on that carbon number, which is really, really good thing. So, for example, about 50% of waste typically is a biomass or a recovered paper type product that originally came from forest products, et cetera. That could be used in many different ways. It could have been a pellet for replacing wood pellets or coal or whatever, but we now see it as a very, very important agricultural supplement. And if we mix it, and this is going to be the carryover here, if you mix that stuff, remember that's 50% of what you're putting on the curb every week, right? If you can mix that in the right formulas, and it's not that complex, right, Greg? But Greg will talk about what it could do with soldier fly and then what it could eventually do for salmon or other species. Meanwhile, about 20% of that bag's got plastic in it that nobody likes. So that's a nasty little problem. And we originally were going to turn that into a fuel, which was going to be used to replace diesel and things like that. But along comes a very large German company that says, you know, we can actually use that to upcycle our whole entire petrochemical process without it having to go through a refinery. So they're coming into town next week, Doug, and we're going to be signing our first deal with them. So that takes care of that part of it, hopefully, for the long term, and we're going to build on that. But I think it's important to note that our path has changed as we've hung around and had more people kind of to collaborate with, and that's really important because we're at the front of this thing, stepping in front of the bus and trying to make use of it. So that's Sustane in a really quick nutshell. I'm going to hand it over to Greg. Oh, yes, there you go.
Thanks, Fraser. I think Paul and I were at the same karaoke bar yesterday, so I have the same affliction, so apologies. Yeah. So I'm Greg Wanger. I'm founder and CEO of Oberland Agriscience, which is an insect farm just located outside of Halifax, or in Halifax, but just outside of the downtown core. Started in 2017 with the vision really of addressing a couple of the global challenges that we have. One is food waste, which is everywhere, and the second is a protein crisis. Among the many other crises facing the planet right now is just that we've got a rising population demanding higher quality feed and foods. So one of the interesting things, and this is a true example of a circular economy here, is how do you link advanced waste recycling company with a salmon farm? I mean, it seems so disjointed, and the way to do it is you put an insect farm in between it. And so this is something that really came out of mutual investors and some really interesting groups as well, talking with Doug and those groups, and us sitting together and really seeing where we connect and on multiple levels. We all as a group, we call ourselves the Super Friends because we don't spend our money on marketing. We have other things that we do. But we get together almost weekly to talk about these kind of problems and how our companies are linked and how we can help each other. So our organization and our operation really starts with organics procurement, and so this is wastes and byproducts coming out of our food industry. we still throw away a lot. And I mean, the programs that are here to reduce food waste, I mean, they absolutely need to happen, but we are still going to have a lot of food waste in our systems. We throw away, I mean, between 40 and 60% of the calories that are produced are lost before they're consumed. That's where we step in. You bring in this insect called the black soldier fly, which will eat just about anything. And we have tried just about every organic in Nova Scotia, and there is only one so far that it has not eaten, and that was the very tail end of what came out of Port Hawkesbury paper. And it was a very noxious solution that the soldier fly didn't like. But everything else we've fed to it seems to have done quite well. We rear these insects in our facility, completely indoors. And the amazing thing about it is it's got such an incredible life cycle. So we go from egg to harvest in 10 days, 8,000 times its size in 10 days is the growth rate. So that's a human infant to a humpback whale in 10 days. And this is why we do this. It's an incredible way for us to produce a lot of protein in a very small space. And we then have multiple downstream products that we can produce. So you can see livestock feed, fish feed. The one that we're just trialing right now actually started yesterday as a big trial over with Coldwater, is a lobster bait. Pet food industry is the largest actually sector now in the insect industry. And then we produce another product that blends very nicely with the wood pellets that Fraser was talking about, and salmon poop. We make a very nice soil amendment that we've been trialing, and I'll talk a little bit about that as well. Where am I now? So where we are now, we're in our pilot facility until June, so we're rapidly running out of time in our pilot facility. We've been there since 2017 and have really taken from around a kitchen table, and actually Barbara is here, who was at that very first kitchen table. We took it from kitchen table all the way through to our pilot facility. We're now operational. We've got a team of about 14 or 15 people now, and we're moving across the street. So this is where we are now. We're producing about 30 tons of larvae a year, which equates to about 7.5 tons of protein. Our frass output, which has gone onto farm fields, and we've diverted about 100 tons of food waste. Where we're going is across the street, and this facility will be up and running in August or September of this year, where we'll be producing about 9,300 tons of larvae. It's a lot of bugs. And one of the things that's interesting too is we talked here about how you can, when you start from the ground up, you can put in a lot of these technologies and stuff that really help. And one of the things we're doing is we spend a lot of time on thinking about this as an energy problem. And so it's the ability to capture and move energy around within our facility, which ends up making a very competitive advantage. Now, the upfront capital is pretty significant on some of these pieces of equipment, but you can see that we're displacing about 10.5 million kilowatt hours a year of energy just through some of these technology upgrades. So that's good for the planet. It's also because, I don't know if people know, but Nova Scotia has one of the dirtiest electrical grids in Canada. So the best thing you can do is, one, get off the Nova Scotia grid, or two, reduce your dependency on it. And so this is where we can really make a big impact.
Good morning, everyone. I'm Dave Roberts, for those that don't know me, with Sustainable Blue. And Sustainable Blue is a land-based salmon farming operation, and we're based here in Nova Scotia. We've been on our particular site now for 17 years. A lot of people find that astounding, me too included. But I've been in this, working in the aquaculture space now for coming on almost 40 years. So I've had the privilege to see the industry progress and grow globally. And you may be aware, of course, that over half of our global seafood is now farmed, and it's only going to increase because we're not able to pull any more volume out of the ocean. We've pretty much maxed that out, as we are really good at fishing. So the question is, how do we increase supply of seafood sustainably? And let me just, so just a couple of shots here. That picture of the site from a bird's eye view, you see in the upper left corner there's a small little Quonset hut, and that was our pilot operation back in 2007. And so we've grown organically over the years, and for the last 10 years have been growing salmon. Started out growing some European sea bass and other exotic species. But we found our biggest competitive advantage wasn't the fact that we could grow non-indigenous species, but basically the process that we use in growing these fish. And the reason we are in multiple buildings is because we've kept expanding and refining our technology over the years. Our biggest claim to fame to date is the fact, when it comes to land-based fish farms, we're the only marine commercial fish farm in the world that has zero discharge. We have no effluent pipe that leaves our site. There are many larger salmon farming operations that are attempting to establish and have established some coastal farms, but they all have a discharge pipe. They all have something that's going back to the ocean or some waterway. And the advantage for us is we develop proprietary technology that allows us to get to that 100% level, and that last 1% is incredibly difficult to get to that level, and it involves more technology and more costs and so forth, but there's huge advantages what you do get there. We take fish, as you can see, from egg, hatch them in our freshwater stage hatchery, and grow them right up to a 10-pound salmon in about 2 years. And that's just a shot inside the building. When you can get to zero discharge, and we're trying to differentiate ourselves, so we invented a new term. It's called ZRAS, and this is the Zero Recirculating Aquaculture System. The benefits are now we need very little new water, and new water is only needed for evaporation or water losses or things of that nature. So we can basically treat that water and sterilize it because it's affordable to do so. And therefore, we have a huge disconnect between the ocean and ourselves. And we don't have any of the issues that they do in the ocean, such as pests and disease, thereby don't need any antibiotics or therapeutants and so on. And so in all our 17 years, we've never used any antibiotics or any therapeutants on and our fish are healthy. And it also, of course, protects the ocean. We're not putting anything back to the ocean, whether it's organics or what have you. And really important is this site independence. Because we're not dependent on new water supplies coming in, we then can relocate closer to the marketplace. For example, we can actually now operate almost any scale of our operations strictly on the rainwater we would collect off the roof of our buildings. And so we don't even need any groundwater supplies on our source either. And we can be inland. We have an opportunity coming up for the state of Washington where all of us actually may end up going there. And we're purposely looking to be inland, away from the coast, so that we can demonstrate these technologies. Of course, being zero discharge was our primary goal. It was our first goal in looking at how to be more sustainable. But as we've talked about already, there are a lot of other aspirations related to the development of sustainable aquaculture. The low-hanging fruit is sustainable proteins and feed ingredients, which Greg will tell you how we're tackling that, along with Mark from Small Food and so forth. Trying to find truly sustainable alternative proteins rather than forage fish going into diets for salmon. And we can get into more of that, of course. And of course, energy. One of the oppositions or people who are in the ocean farming industry will say about land-based is, oh, well, you guys use a lot of electricity. And it's true, relatively speaking. So we're looking to, one, lower our footprint, but also getting on to renewable sources. And we've done LCAs between our group, and collectively, we can actually say that our farm, at a 5,000 ton per year scale, will have a lower CO2 footprint than a net pen operation of the same scale, which is quite amazing. And we're trying to be zero waste, not just zero discharge, so that all of our products, whether it be the biosolids coming out of the fish or fish trimmings and stuff, get repurposed, upcycled back into agriculture or other food products. And Greg again will talk to me more about that. I guess that's me.
Okay, so this is now where, as I said, we get together every week. We have maybe a beer, and we come up with maybe a beer, and we've come up with a sort of model that seemed like a really good idea. After one beer, we've now shopped that around, and we've had some very interesting parties that have come through to talk to us. Dave mentioned the state of Washington. Last year, we had the Commissioner for Public Lands in Washington State was here with her team. We toured her and her team around with a whole bunch of other people around, and it ended up with the state of Washington signing a letter of intent with Sustainable Blue and Sustane. We're next. To look at an expansion into the Washington State area. And so this is something that we have gotten together. We colloquially call ourselves the ecosystem, but then again, I said because we don't have a marketing team that is tasked with doing this. But what we're really trying to do is we're all good companies. We're trying to do the right thing. What became obvious was how linked we really were, and how many non-obvious links there were once we really started to talk about things. And so it became really obvious that, why not locate the next site with us on the same kind of campus? And so we've been working on this and talking to some very large operations in the U.S. And different states who are interested in this. And so this is where we start to come up with the idea about this ecosystem. And really, it's the closed loop on one site. So this is kind of how it works from a conceptual level. Really, we start with, at the top end of it, is the municipal wastes and organic wastes that are produced in any region where there's a significant population. That feeds into Sustane, and Fraser mentioned too what their magic black box of technology does in separating all these different organic, or these different waste streams, putting them into higher value streams. The organic side of things, sort of the goopy stuff that falls out of the bottom of their machine, comes into the Oberland system as an insect feed. We rear the insects. That becomes then a salmon feed or protein for other agriculture, aquaculture, pet foods. And then there's two other companies here. Mark St. Onge, it was mentioned, Dave mentioned, he's here in the audience as well, with Small Foods, which is a single-cell protein company. And then Beth Mason, wherever she is, right in the back there, started a company called Scaldier, which is a way to valorize the racks and heads and viscera of the salmon to add value-added products here. And so even over the time, as we've started to develop this ecosystem concept, new companies and new groups have sort of been merged into our little group here, because it just seems obvious to have us all kind of working together. And so here you can kind of see this sort of cascading of materials, and there's a whole other layer of stuff that is not in here about sharing energy and heat and stuff like that between the different companies as well, that really ends up making this system seem so great. Does it actually work? I mean, right now our companies are each about, except for Mark and I, who are maybe about 10 kilometers apart from each other, but the rest of us are all about 80 to 90 kilometers apart from each other. But what we have done is, in every connection between our companies, we've proven that we can do it. So we've had a couple of projects that we've worked on. One is a feed project, which is currently ongoing. We're in our third phase of a trial, and this is with Small Food, Oberland, and then another company in the U.S. Producing a feed that is very specific for wrasse-based salmon farming. And so this now has been very promising, and we're all very excited for the end of this trial, because there's a taste test, and I can't wait for that. The second one Fraser mentioned too is that, Sustane has kind of changed its path in where its products are going, but we were actually one of their first clients. When they were still using their products as fuels, they needed someone to test this, and we took the first batch of their fuel and have been heating our facility, our pilot facility, which still uses an oil furnace. Our new one does not. But we were the first client, and that has been really fun, and it's been great for us to tell the story that we're using Halifax's plastic that was destined for the landfill to heat our facility. And then finally, a lot of our products too are co-products that we're all producing. So the wood pellet, the frass, which is the poop from the soldier fly, and the salmon poop has been trialed now several times as a fertilizer, and it's a tremendous soil amendment. So we had a project last year and this year where we grew cabbages with a local farmer, and there's the product of our efforts. Delicious cabbages, by the way. So here's just the feed. Do the salmon like it? That's always the big question. Of course they do. Otherwise, I wouldn't show the picture. But here's some baby salmon eating some soldier fly. It's a natural feed for a salmon. I mean, people at first seem grossed out by it, but then you say, what do you think the salmon are eating in nature if they're in the rivers? It's insects. So it's a natural thing. And it floats, right? So this is one of the things that, I knew nothing about salmon feed. I knew even less about the lobster industry, and now all of a sudden we've forayed into that quagmire? No, it's not a quagmire. It's actually it's a market. It's a very positive market. But But one of the things that we're looking at too is what is the impact of this campus? And here is sort of a high-level approach at what the campus can look like for a community. So one is basically all your waste of your community can be taken care of within this ecosystem. But then also there's the knock-on effects, right? There's the jobs that are created. You know, there's always this thing, you know, when net pen aquaculture comes out, when a region says you can't do net pen aquaculture anymore, there's always a scream for like, well, what about the jobs? They're not going anywhere. They're just coming on land, and they're actually now, you'll be working at Sustainable Blue instead of out in the water. We also have done, Dave mentioned too, the life cycle analysis. So each of our companies, and I want to thank the Innovation Hub, which is now changed. Greenspring. Paul. Shameless plug, helped us actually with this project where we each had our LCAs done for our individual companies, but then we went the next level to see what it looked like when we linked them together, and that's where Dave came up with the metric about being lower CO2 footprint for the final product than the competitor.
If I can add, that is 5 to 10% per capita of all the emissions, if you start measuring it that way. So
yeah, no, it's good. So this is really the kind of stuff that we're looking at here. It's interesting to hear the talks earlier about measuring the CO2, because one of the things that we as a group are really looking at is how do we measure the carbon as it flows through our system so that we're not double counting and so that we get a true understanding of our intensities. And we're thinking big. So these are the kind of ideas that we have. We are in discussions with several groups, as I said, across the US, and to actually see the concept really come to fruition. And yeah, be happy to take any kind of questions from people.
Thanks for the presentation. Really inspiring how you've interconnected the whole supply chain and recovering otherwise waste product. I'm curious, Greg, you mentioned in the new facility doing the energy distribution around the facility. What is some of the thought process that went into that? Or maybe for the others, any other energy efficiency measures that you've looked at to reduce those emissions?
Sure. For me, even early on, it was for every kilowatt hour we save is one we don't have to buy, right? It really came down to that. You know, we're spending whatever it is, 17 cents a kilowatt hour, plus this is from Nova Scotia Power's website. It's about 650 to 700 grams of CO2 for every kilowatt hour that you purchase from them. It just seemed like a great idea. It also, so the soldier fly is a semi-tropical species, so it likes it warm. So our facility, or at least part of our facility, is 28 degrees year-round. Well, it is not 28 degrees year-round in Nova Scotia. And we have a massive, for instance, energy or requirement for fresh air to bring in because we've got 700 million bugs growing at a single time. They all require air. So how do you match that? We can't just be bringing in cold air and then venting out hot air. So we're putting into our new facility, we're putting into a very sophisticated heat recovery system that actually takes the excess heat at about 95 to 97% efficiency, puts it into our water loop, and we can use excess heat in our domestic hot water. We're actually using it in the radiant floor heat for the rest of the building. And all of that stuff kind of came in, was relatively easy to do on the early stage. This would be impossible to do later on because you can't put a radiant floor system in after the fact. So there was a lot of planning that went into how can we move energy around, where are we massively using excess energy, and you know, we have a heat requirement here and we have a chilling requirement here. Can we do that internally? And that's really was where a lot of the thinking came. And then there's the obvious, you know, you put solar on the roof, you buy your power from wind instead of from NSP, and those are the kind of the easy ones. So yeah.
I can just give a little example about the benefit, I guess, of being 100% versus even, say, 99.5% recirc. There's always a baseline of water from evaporation and fish losses and waste that takes water with it when it leaves. So for a 5,000 ton per year farm, salmon farm, that's roughly around 8,000 gallons a day that you would be replacing. If you were at 100%, that's what we would be. If you're at 99.5%, that's still quite a high number, and a lot of people aren't there yet. That 8,000 transfers into 2 million gallons a day that they need to bring in new water. So that's a big jump. If you go up to say 99, you're up to almost 5 million gallons a day, and that's water that's going out, so therefore you need that equivalent water coming in. It all has to be heated or chilled or whatever species you're growing, and so just by trying to get to that 100%, you can significantly reduce the energy requirements. Now, we're of course looking internally. We want our energy requirements to be even lower than they are now, so we're investigating similar types of processes that Greg's been mentioning as well.
Just add a quick point. Quick point too, in our process, I didn't explain it, but we, in order to create the thermal load for the system that we have, we use some of the plastic, and a little bit of that fuel goes back in. So we're thermally self-sufficient, and we have the ability in a next generation plant in this campus actually to be completely off-grid as well, because the turbines we're going to use for producing the fuels, the synthetic fuels that are going to be plastic, those turbines are going to overproduce both heat and electricity. So,
I think I'm going to, one more question.
I'm just wondering about the cost impact on your end product, whether or not you're able to produce cheaper, and whether or not you have gotten, or we have gotten to a point as a society where you can actually demand a premium price for a more sustainable product.
I'll start because we're way upstream in terms of this. So remember with waste, and there's an ever-increasing regime right now where there's tipping fees involved. But we've proven actually in our model just getting a market value for products, and again downstream, both Greg and Dave will talk about the ability that that they can add economic value to this. But for us, just getting that market value produces a return on investment with a zero tipping fee. We don't advertise that because that's a little too disruptive. But the point of the matter is, garbage and waste is a very expensive thing for the community. So we're off to a very, very good start with that. I'll stop there.
So we've, we've done, I mean, it's hard because we're relatively new. The insect industry in Canada is not that old. There's really only two sort of larger scale operations. Globally, though, you see the insect industry is trying to push for this sustainability. What I've found actually in our modeling too, if you look at our cost of goods, like yes, there's an initial upfront capital cost, but if you do the return, so our heat recovery system, while very expensive, is saving us so much power that the payback is about 2 years. And hopefully the system lasts longer than that. But I mean, that is the metric that we're doing. What that allows us to do is to be really cost competitive because our COGS are lower. Secondly, we've invested very heavily in robotics and AI and that kind of stuff. That's allowed us to reduce the number of people we require to keep our operation going. That too translates directly into making us more cost competitive. We do have some clients that are approaching us that do see the benefit, and actually part of the reason that we are measuring as much stuff as we do is that they then can use that to help tell their story better. And so that's really where we see ourselves, is we allow, for instance, Sustainable Blue to tell a better story about their feed. And at the end of the day, maybe we can charge Dave a little bit more for the product. So,
not going to happen. When it comes to the products like salmon, of course, we're directly competing at some level with ocean-based net pen salmon, which, well, they're the majority of supply right now and will be for some time. So, if you think about organic products, people kind of expect that they'll pay a bit more for that because there's intrinsic value to them in what they're offering with the organic certification. Our products our salmon is, if you look at organic certification for aquaculture products, we're actually beyond a lot of those things, even though we're not marketing it per se yet in that field. So we understand there is a premium available now for land-based salmon. The marketers have two SKUs. They have farm salmon, which is entirely net pen, ocean-based salmon. Then they have wild and land-based in another SKU. So there's sort of that dichotomy in the consumer's view. That may not remain over time. It may get a bit more muddled as different net pen operators choose to do land-based, but in a less sustainable way than we are. In addition, long-term, we expect that the volume of land-based salmon will come up, so we want to be competitive on a market on a fish-by-fish basis. When it comes to feed, we see, of course, feed is about 50% of your direct operating cost in any, whether it's net pen or land-based. We can be a bit more efficient because we can monitor that more closely. But the ingredients, of course, that are going in there, it's all cost-driven largely at the net pen operators, where they're trying to get a low cost. Doesn't matter really what's in there as long as the fish grow, whether it's chicken feather meal or you name it, we'll feed it as long as the fish eat it. We've taken a different approach where we want to put feed ingredients that are natural, and the fish have evolved to eat them, and therefore they have good gut health, good immune systems, they're healthy, happy fish, and taste better in the end for consumers. And that story also resonates with people. And the ingredients that we're looking at, they're probably at the top echelon of cost per ingredient that would go into a diet. It'd be an expensive diet. We still see that we can utilize that and still be competitive in the marketplace currently. What's happening, though, is because we're running out of forage fish and ingredients to put into diets, the price for those ingredients globally are going up as well. So I fully expect over time that our ingredients will get surpassed by forage fish ingredients and will be a cheaper diet long term, because we can control those productions and they'll become more efficient over time as well. And the buying population that's rising up into the marketplace now is a lot more dialed in than my generation was about, and the first question we ever get about somebody wants to know about our fish is, what are you feeding them, right? And what are you doing with the waste and these types? So these are all going to have some intrinsic value, which will transfer into a market price as well.
Sounds like he's not going to pay any more, Greg, right now.
So I think we're ready for break here. We went over our time, so I gotta. Yeah, but I'd like to thank our speakers here, and if anybody has any questions, seek them out in the networking break. So we'll go to break right now.